Hi everyone, this is Satyajit. Welcome to my channel Cloud Journey with Satyajit. Today we are going to discuss about one interesting topic which is called private connectivity type of NAT gateway. We already aware about what is NAT gateway. Okay, so the use of NAT gateway is to access internet or access outbound internet from the private network. It means like if any private EC2 instance wants connectivity, let's say like your database wants to, if your database is running on private subnet and you want to install some of the packages, or you want to install the latest features or something, applications upgrade, that time you require internet connectivity. So at that same, as it is in private, so there is no internet gateway attached, right? So on that scenario, we can use NAT gateway, so that what happen, using the NAT gateway, we can able to access the internet. And your NAT gateway is created in a public subnet, and NAT gateway have an elastic IP. That we understand about the public connectivity. Now we can understand that two connectivity options are present. Like one is public connectivity and another one is the private connectivity. So today we are going to discuss about what is the use case of private connectivity type. So to understand that, we need to understand the problem statement. Now, let's say in the diagram, I have a two VPC. Okay, this is a belong to one customer, and that customer has two VPC, VPC A and VPC B, and both they're created the same CIDR range, like 10.0.0.16, and another one also same 10.0.0.16, and some of the applications are many applications running in both the VPCs. So now there is a requirement in the VPC A, one application which is running on EC2 A wants to connect to EC2 B, which is running on VPC B. As both are in different VPC, we must have to create VPC peering, or else we can create a transit gateway and the attachment. So here, as both are in the same VPC, or both are different VPC, but same CIDR range. So we cannot create the peering connections, because peering connections cannot be made when the CIDR overlap with each other. So we cannot make the peering connections. Next is transit gateway. Okay, and if we create a transit gateway, we can able to create the attachment. But while the propagations, once we do the attachment and once we do the associations, propagations will happen automatically if we select the default route table, right? Default route table associations and default route table propagations. So in that scenario, if they want to communicate as both belong to same CIDR, so there will be conflict. So transit gateway will not understand which services or which EC2 instance it is asking to connectivity, right? So in that case, it will not be helpful. Okay, so how the private connectivity options of NAT gateway will help to make the connections between two VPC who's having the same CIDR range. Okay, we are going to discuss in that. Okay, well, let's jump into the practical. Before that, just see the architecture diagram. Okay, and let's say it's a overlapping VPC A, which is 10.0.0.16 series, and another is overlapping VPC B, which is also 10.0.0.16 series. And we know same series or same CIDR range, we cannot create the VPC peering connections. Okay, so for that reason, what we will do, we have to create another CIDR range. Okay, another CIDR range for that. Like we know, like the VPC, we can create multiple CIDR range. Okay, so we can create additions multiple CIDR range. So once we created the multiple CIDR range, also if we try to do the peering, then also it will not be, we cannot make the VPC peering connections because one CIDR range is overlapping. So on that scenario, we need to create a transit gateway, and in that transit gateway, we need to create the attachment, which is the extra CIDR range which you have added. Okay, to make it simpler, what we will do, already I have a VPC. Okay, if I go to, if I'll show my screen, so I have two VPCs present, VPC A, which is 10.0.0.16 series, and VPC B, which has 10.0.0.16 series. So what I will do, if you go to the subnet and VPC A subnet, Okay, they have two subnet. One is public subnet. If you see, public subnet has a route table towards internet gateway, and there is a private subnet. There is no route to the internet. Okay, there is something called okay, that we will talk later. Next one is the VPC-B. Okay, if you specifically see the VPC-B, there is also one public subnet where is a route table attached to internet, and there is a private when there is no route to the that's this NAT gateway is there, but that is in um, this NAT gateway is in a black hole state because it was created but now it got deleted. Okay, if you can verify, go to the NAT gateway route table. If you see the black hole means that is not present now. We can able to remove also. Okay, so now I have a two VPC. Now what I will do, I will create two EC2 instance, right? So one in VPC A and one other in VPC B, and they want to communicate. Let's do that EC2 instance setup. If you go for the EC2, I'll just create instance, launch instance. I will just give you this a name, EC2, something like EC2 BPCA, something one instance type, and I will do everything by default. Only when I select the network, I will specify BPCA, and public subnet I will specify auto assign enable, and security group I'm just selecting by default. Everything same. Launch instance. I created one instance in VPC-A, and next instance I'm going to create in VPC-B. I'll just create EC2 VPC-B, and the rest of the things are same. Key pair only I need to add, and this time I need to select the VPC-B and public subnet auto assign enable, and other thing remains same. So now two EC2 instance created. If you see the diagram, now in the one instance I created public subnet and another instance I created in the public subnet. Okay, and I cannot do the peering connections. Okay, next step is, so we can create a transit gateway. We can create a transit gateway for that. But before to that, what we will do to make the communications between the VPCs, we can add another CIDR range. You can add any other CIDR range, but the CIDR range which you are going to add for the VPC A and on the VPC B, that should not overlap. Okay, so here I can just use 100 series something 164.00/24 for VPC A, and there is something 164.1.024. So both are not overlapping with each other. So what I will do, I'll just go to the VPC A actions and edit CIDR, and here add CIDR. Okay, I can just make 164.0.0/24 something. So you can take anything. Okay, something added 04024, and next you can just go to the VPC-B and edit CIDR, and this time I will just make it as 164.1.0/24. Okay, so two CIDR I have added, extra CIDR I have added. Now the time is I need to create the transit gateway to make the communications between that. Okay, so to do that, next step is you need to create a transit gateway. So I will just go to the transit gateway, create a transit gateway. I'll just make it as test transit gateway, something. I just added the name. You can just add something. This is the TGW created for testing, something. You can just add it. This time make it sure like the route table associations and propagations we need to disable. It means we are not going to use the default route table. We are just going to create a static route table. I just disable that options, and that's it. I just created transit gateway. Okay, and it will take some time to be available for that transit gateway. It will take 2 to 3 minutes of time. By that meantime, I'm just pausing the videos. Till the transit gateway. Okay, now transit gateway is in available state. Okay, transit gateway is created. Next time, next one is, now if you see the diagram, now this public subnet, private subnet is already created. Next is we need to create a NAT subnet, another private NAT subnet, where I'm going to create the NAT gateway, but that subnet will be from the the secondary CIDR range which I have taken 64 something, I need to create that side subnet, okay, from that CIDR range. So what I will do, I will just go to subnet and create a subnet. This time specify the VPC A, and I will just named it as something public, not public, it should be private, okay, private subnet nat -a something, okay. You can specify, okay, and here you need to specify your secondary VPC, okay, and you can just create a CIDR range 100 64.0.0/28, whatever the things you need to create, you can just going to use it, okay. Once that is done, create a subnet, but that subnet should be private subnet. So how to make that private subnet? You can just click on the subnet and route table, okay. Now you need to go to the route table to that VPC A, and there is a private route table. Here you can go for the subnet associations, edit subnet association. Now add the private subnet association. So now it is a private. If you don't it by default, it is go for the default one, which is the public one. Now VPC A is done. Now you need to go for the VPC B. It means you need to create another subnet of VPC B, and this time you need to specify the name like private subnet route something, private subnet nat -b. B stands for VPC B, okay. You can specify US East 1. This time you specify the other side range. This time 100 64 1.0/28 something, okay. You can take by your own. Create subnet. Now subnet you have created, same thing, you need to go to the route table, and this time specify the VPC B, okay, and the private route table, subnet associations, and that specify the private subnet nat B, okay. So now what I have created, one pair of subnet each, and that is of the secondary CIDR range, not the primary CIDR range, okay. Once that is done, our transit gateway is already created. This time we need to create the transit gateway attachment, okay. So now we need to go to the transit gateway, and I have to transit gateway attachment, okay. Okay, so this attachment earlier I've created, this is in deleted state. Now create the transit gateway. This time just name it as TGW -A. So stands for transit gateway attachment A. This time select your transit gateway attachment type is VPC, and which VPC? VPC A, and specify the subnet, the NAT subnet, okay. That's it, NAT subnet, and create the attachment. Now one attachment you have created. Now create another attachment. This time we'll specify TCW B, and specify your transit gateway VPC type of attachment, and select your VPC B, and this time same private subnet NAT B, okay. You have to select the private subnet NAT gateway, okay. Now transit gateway attachment. So now you have created two attachments, so TGWA and TGWB, which is in pending state, okay. Transit gateway, it must have a route table, but we did not create the route table. So we need to create a route table which decides how the communications can happen. So to do that, you need to go for the transit gateway, and we need to create a route table, okay. So here you need to create a transit gateway route table. Let's say TGW route table something you have to create, and specify your transit gateway, and that's it. Create the transit gateway. Once you create the transit gateway, it will take some time to be available, your transit gateway and also your attachment, okay. You can just verify transit gateway attachment, they are in still pending state, and your transit gateway route table also, that is in pending state. It will take some time. By that time, refer the diagram. So what we did on the VPCA, we have added one extra CIDR range, and our public subnet and private subnet already there. I created one EC2 server, that is my source server, and on the private NAT, I have a private subnet I have created. That's it, okay. And then I have created the transit gateway in the secondary VPC also, like your VPC B, your public subnet and your private subnet created, and here is your destination server. And on the private NAT subnet I have created, and I have created the transit gateway and transit gateway route table. That is done, okay. So now what we need to do, attachment also I have created, like this time attachment also I have added. Now we need to associate the route table and do some associations and propagations on the transit gateway side, and then we need to test it. Okay, so before do that, let's see whether it is in availables. Okay, transit gateway route table is in available state, and your transit gateway attachment also in available state. Now you have created the attachment. If it is a default route table, it will be directly associated or propagated, but as we created the custom route table, we need to do the association. So we need to go to the transit gateway route table, click for association, create association, select your GWA and association. So once association created, next is create another association and go for TGWB and create association. So now your both association is created. It will also take some time to be associated properly. Now association is created. You can create for propagations. If you go for propagations, you can create a propagation, select same attachment. So if you see the attachment, right, it will take by default all of your VPC CIDR range full one, right, the subnet one. So instead of that, we can create our static routes. Okay, static routes means only to the specific subnet which you have created. Okay, now our attachment is associated, right, association is done. Propagations we can directly make it, but propagations it will take to the whole secondary CIDR range. Okay, instead of that, what we will do, we just create a propagation static routes. Okay, we can create a static route. In here we can just specify your IP 100.64.0.0/24. Okay, and its attachment is TGWA. Okay, create a static route. This is one propagations, one static route. Sorry, your routes, one route I have added. Next route is here 100.64.1.0/28, I guess. Sorry, my bad, I just added wrong, or maybe TGWB and create static routes. No, now two routes I have added. Let me see. Okay, I just added 24. I can just edit it. Okay, I think I cannot make it. So what I will do, I'll routes, and I'll just remove it. Actions, delete static routes, delete it, and I will just create a new one again. It is in deleting state. Okay, it's deleted. Create static routes. Now this time 100.64.0.0/28, because your everything resources are present in that one. So create static routes. So now a route also added. So now everything is done, right? Your transit gateway created. Like if you refer the diagram, your transit gateway created, and your subnet is added. This subnet is also added. Now the main thing is we need to create a NAT gateway. Okay, and NAT gateway should be created in the source side, because my source system wants to communicate the destinations. If your destination system wants to communicate source, again destination side NAT you need to create it. But now my requirement is from source side. So what I need to do, I need to go to your VPC and I need to go to NAT gateway and create a NAT gateway. This time I'll just make it as, let's say, private NAT. Okay, and subnet you need to specify the private subnet NAT A. Okay, private subnet NAT A stands for VPCA, and connectivity type is private connectivity. Okay, it doesn't require any internet, and create a NAT gateway. So it will again take some time to the state is in creating state or pending state. It will take some time to be available. By that meantime, we can check all the route tables in detail. Okay, so now here VPCA, and this is your private subnet, and the main communications required the resources from here, because NAT is here. The communications from NAT to, again, it will go from this NAT. Okay, so what we will do here in the route table, private route table, we need to attach the transit gateway. Okay, and here also, like, the source wants to connect to destinations. Again, destinations will give the packets to source, right? On that case, from the source route table, we need to add the destination CIDR range, like secondary CIDR range, and communications will go via the transit gateway. And also in the destination side, source CIDR range and communications will go via the transit gateway. That is one thing. Now from the source server, request is going, once the source server hit the destination side or IP, then request immediately will send to the NAT gateway IP. That's the reason if you give, this is the secondary of the VPC-B secondary IP 164 one, it will go to the NAT. So that route level changes, we need to make it before the NAT gateway should be available. So what I will do now, I will just go to the VPC-A and to the route table, and VPC-A I have two route table, public route table where your servers present. So what I will do, I will just edit the routes, and this time I will just make 164.1.0, and this time I will just select the NAT gateway. So NAT gateway, which is I created private NAT. Okay, so private NAT, and save the changes. So now what happened, I added the NAT. If you see here 164.1.0.24, it will be going to the NAT gateway. You can verify here 164.1.0.24, it will go to the NAT gateway. Okay, and next you can see other route table, other everything. Local means it has two CIDR range, that's the reason local, and 0 means your internet gateway, and NAT gateway we have added. So total 4 routes. Okay, you can just verify here. So it should be total 4 routes. Now we can just go to the private route table. Okay, you can just verify the route table, and we can just go to the private route table, routes, and edit routes. And here instead 164.1.0, it will go via the transit gateway. So you can just select the transit gateway and transit gateway attachment A, TGWA, and that's it. Save changes. Okay, so now this thing is done. Our VPC-A side is done. Now our VPC-B side. VPC-B side, there is no source or destination. VPC-B is the destination, so there is no NAT. So I just have to do only for the the private one. Okay, so in the private one route table, you can just go to the edit routes. So now we can just add routes and 100. Okay, in the private one, sorry, on the private one, your 164.0, this is your VPC-A primary, right? So you can just come here 100.64.0.0/24. Okay, and it will go via the transit gateway. Okay, you can just add the transit gateway B, and that's the changes. Okay, so now everything is done, communications, everything is correct. Now you can say NAT gateway should be in available state now. And just verify, yeah, NAT gateway is in available state. So we are done, almost done. Again, now the communications, now every communication is there. Now from source server, when it will come to the request, here ENI means whenever we create a transit gateway in that VPC, right, in that subnet, the ENI will be created. So here one ENI and here another ENI will be created. Okay, so now request will hit. So this source server wants to communicate with the destination server directly. So directly server. So instead of that, what we will do, we'll just create a network load balancer. Why? Because your NAT gateway will not do the source and destination check. Okay, because this is a private NAT gateway. For that, we need to create NAT instance, and again it will be a very much clumsy. So to do that, what we will do, we'll just create an internal network load balancer in front of the destination server, and we will, from the source server, we will try to hit that network load balancer, and we'll see communication is happening or not. So to before doing that, I will create a network load balancer. Okay, so in the destinations, so destination means my EC2 VPC-B, I will just try to install some basic applications. So what I will do, I will just access it, SSH-i. Okay, I will just go to the respective folder, SSH-i, and okay, I connected to the server. So I will just do the yum install httpd-y, and it is installed. Now I will go to is the HTML file, cdvar www.html, and I will create one index.html. Index.html. Okay, I will just create it. Okay, sudo vi index.html, and here I will just hit it. This is this is the uh, this is server 2 from VPCB something. This is server 2 from VPCB something I wrote, and I will just restart the application. Service HTTPD restart. Okay, once the application is done, I will just verify from the security group the 80 port open or not, because application is running on 80 port, or else it is not going to work. So I will just do HTTP and 80 port it to anywhere. Okay, once that is done, so now if I verify the applications, okay, application IP, there must be, it will show the content. Okay, once you hit that, uh, sorry, yeah, this is server 2 application is running fine. Now I'm going to create one network load balancer. To create a network load balancer, first we need to create a target group. So what I will do, I just created the target group. You can just create a target group, and here in the target, we can just register a target, and this is my EC2 VPCB target, and include as pending below. So I added the target group here. Okay, now I can create a load balancer, and that load balancer must be a internal load balancer, network load balancer. So I'll just create it, new test something I added. It must internal, and you need to specify your VPC, this time VPC B, because it is created in the destination side. If you see the diagram, load balancer will be created in the destination side. Okay, so now in VPC B, and you need to specify your subnet, private subnet NAT B. Okay, and then your security group something default added. Then this time you'll specify your target group. Other things will remain same, and just create a load balancer. And once the load balancer is created, and verify your load balancer security group must be 80 port open to the world, right? You can just verify. Okay, all traffic open, but no, it's default route table, right? So, but you can just make it as HTTP anywhere and save the rules. So now I have added the security group. This is fine, and it will take some time the network load balancer to be available state, and the network load balancer, it is in provision state now. It will take some time. By that meantime, I will just pause the video. Okay. It took almost 5 to 10 minutes of time to the network load balancer to be in available state, and the target to be in a healthy state. So now my network load balancer is in running. So if you verify, my network load balancer is in running state now. It is in active state, and also our target group is, if you close this and if you see the target group, and target group is in a healthy status. Okay, so now my network load balancer is working fine. So now this is an internal load balancer. So this now the time is, we need to verify and validate the communications from the source side to the network load balancer. So my source machine is 10.0.0.0.124. So I already connected, and from here, let me install the telnet here. Okay, once I do the telnet installations, so from here I'm just going to validate the communication. So this is my DNS name, and I will just hit here the call command. So to validate I'm able to resolve it or not. Okay, so I can just type call this one. If you see, this is server 2 from VPCB. Through internal URL, internal load balancer URL, I can able to hit it. You can just do the telnet, and application is running on 80 port. I can able to see the status is showing connected. It means from this my source server, whenever I hit the request, it reached to the private NAT gateway, and from private NAT gateway it reached the transit gateway ENI, elastic network IP. Once it is reached, it is going via the attachment and reach finally the ENI of the destinations, that NAT gateway. From there it will go to the network load balancer, and from that network load balance directly reach to the destination server. So in via this way, I can able to make the communications both the CIDR range are similar, both the CIDR, because my application is present in the same CIDR range, but still I can able to make the communications between them. Okay, now this time let's say this destination server wants to communicate with source server. So this time we need to create a NAT gateway here, private NAT gateway here, and again there will be a network load balance will be presented here. Okay, so this is just a the one part of the private NAT gateway. There are many more things, right? What is the use cases of what is the benefit of private link and that NAT gateway, we can see, and that will come in different next videos. By that meantime, you can just verify the setup and validate it. If you have any queries, let me know. I will help you out. Thank you for watching my videos. Thank you.